Hello again and welcome back to the next video, and this video is in the continuation of the 970932, and we have solved the previous entries from October-November 2019, and we have solved the previous 4 questions in the previous video, and this is the 5th question. The equation of a curve is this: 2x square y minus xy square is equal to a cube. It is given, y is given in the implicit form, implicitly given. So where a is a positive constant, show that there is only one point on the curve at which the tangent is parallel to x axis. So tangent is parallel to x axis, so we need to find the dy over dx first of all. So implicitly, how do we do the differentiation? For that we are going to use the product rule. Here it is 2x square. I'll take this 2 as a constant, x square as one function, y is as another function. I'm going to do the differentiation of both the side. We'll get 2 into x square as it is, and differentiation of second function, it is dy over dx, plus second function as it is, that is y as it is, and differentiation of x square, it is going to be 2x, minus, again it is the product of true numbers. So first function as it is, differentiation of second function would be y square is 2y, and y differentiation with respect to x is dy over dx, and plus y square as it is, and differentiation of x is 1. So if you have doubt that why it is y, how y square differentiation is 2y dy over 2y dy over dx, it is like if we are doing everywhere, it is like x square differentiation is also 2x into dx over dx, but we don't write dx over dx because differentiation of x with respect to x is always 1. So that's why we don't write it. Here we have y and we are differentiating with respect to x, that's why it is dy over dx here. Is equal to 0 because it is a constant, a is a positive constant. So now we are going to collect the dy over dx from here. I can see dy over dx here and here as well. So I'll write 2x square minus 2xy dy over dx, plus 2 to the 4xy, and this is minus, so minus y square is equal to 0. So from here again I can see it is x common, but I'll transfer it to the other side and I'll write dy over dx directly. It is going to be y square minus 4xy and whole upon this thing, and I'll take 2x common, it is going to be x minus y, or we can rewrite it again, y common, and we got y minus 4x whole upon 2x common, it is x minus y. So dy over dx is this. So for tangent parallel to x axis, tangent parallel to x axis means slope is 0, it means dy over dx will be 0. So for parallel to x axis, the tangent parallel to x axis, dy over dx should be 0, and we know dy over dx will be 0, it means the denominator cannot be 0, here denominator cannot be 0, only this numerator will make it equal to 0. It means y minus 4x, y times y minus 4x is equal to 0. So from here we got y is equal to 0 or y is equal to 4. So for y is equal to 0, we will not take y is equal to 0, the only y is equal to 4x is possible, because when we will put y is equal to 0 here in the main curve, equation of the curve, we will get the left hand side as 0 and right hand side which is a cube, and it is a positive constant, so of course it is not possible. So in order to find the x values and y values, we will put this y is equal to 4x in the equation of the curve, and we will get 2 times x square into 4x minus x times 4x whole square is equal to a cube, or from here we got left hand side become 2 4s are 8, 8x cube minus 16, 4 4s are 16, 16x cube is equal to a cube. and we know it is going to be minus 8x cube is equal to a cube. So x will be, I can write directly, it is going to be cube root of a cube upon minus 8, that is going to be a over minus 2. So x coordinate is a over minus 2. So once we got x coordinates at x coordinate where tangent is parallel to x axis, so we can get the value of y also. So from here, if x is equal to, we know that x is equal to y is equal to 4x, so x will y is equal to 4 times minus a over 2, that is going to be minus 2a. So here is the question number 6. The variable x and theta satisfy the differential equation sine half theta dx over d theta is equal to x plus 2 cos of half theta, and theta is in between 0 and pi. It is given that x is equal to 1 when theta was pi by 3. Solve the differential equation and obtain an expression for x in terms of cos theta. I'll separate the variables. 1 over x plus 2 and dx is equal to cos 1 over 2 theta upon sine 1 over 2 theta, and integration of this with respect to d theta, because this will go that side. So when we'll integrate it, it is going to be ln modulus x plus 2 here is equal to, this is cot theta, and I'll not take it as cot theta. I'm going to substitute the value of sine 1 by 2 theta as t. If it is t, then cos of, because differentiation of sine 1 by 2 is cos of 1 by 2 theta, and if, then chain by chain rule it is going to be 1 upon 2 multiplied by here, and d theta is equal to dt. So 2 will be multiplied, so cos 1 by 2 theta d theta is equal to 2 dt. So it become 2 dt over t. So integration of this will be 2 times ln modulus t plus a constant of integration. And now we can rewrite the t value in the terms of theta. So ln modulus x plus 2 is equal to 2 times ln sine of half theta plus constant. Now it is given that when theta was 1 pi by 3, x is 1, so it would be ln 1 plus 2 3 is equal to 2 times ln sine theta, theta was pi by 3, so 1 by 2 into 1 by 3 is pi by 6, so sine pi by 6 is 1 by 2 plus c, and we can rewrite it as 2 times ln 2 inverse plus c, or it is going to be minus 2, and I'll take 2 to the power and ln 2 square plus c, or we can write c as ln 3 plus ln 4, and we know it is going to be multiplied because there is a sum between them. So c is equal to ln 12. So once c is equal to ln 12, we'll replace it here, and we'll get ln modulus x plus 2, ln modulus x plus 2 is equal to 2 times ln sine half theta plus ln 12. Now we can write it as a single log function. It would be ln sine square half theta, because it is 2 here, so it would be square, and then there is no need of modulus, and there is a plus, so we'll multiply by 12 also. So it is ln. So we'll remove log and we will get x plus 2 is equal to 12 sine square half theta, and we need to get in the cos form, so it would be 12 times, we know that cos theta is equal to 1 minus 2 sine square half theta. So from here we can get 2 sine square half theta would be 1 minus cos theta. So I'll write 6 in place of 12 because I required a 2. 6 into 2 sine square theta by 2, that is 6 into 1 minus cos theta. So from here we got x is equal to minus 2 plus 6 minus 6 cos theta, or we got x is equal to 4 minus 6 cos theta, and that is the x in terms of theta. So I hope it is clear. Let's do the next question. Here's question number 7. Find the complex number z satisfying the equation z plus iota z over z star minus 2 is equal to 0, where z star denotes the complex conjugate of z, and give your answer in the form of x plus iota y, where x and y are real number. So x and y are real number, and this is a so let's assume that z is equal to x plus iota y. So it means the complex conjugate of this, that is z star, would be x minus iota y. So let's multiply this equation, whole equation, by z star. So if we multiply the whole equation by z star, we will get z into z star plus iota times z minus 2 z star is equal to 0 into z star, that is 0 only. So now we will replace these values here, and we will get it as x plus iota y into x minus iota y plus iota times x plus iota y and minus 2 times x minus iota y is equal to 0. So let's simplify it, and we know that iota square is equal to minus 1, that is what we are going to use, and simple algebra. And then x into x is x square, and it is x into minus iota y, so minus x iota xy plus iota times xy minus iota square and y square plus iota x, this into these two bracket, this bracket, so plus iota square y minus 2x minus minus plus 2 iota y is equal to 0. And now there is a iota square, these two will be cancelled, they are same, iota square, so I will put it as minus 1 in place of iota square. You will get x square plus y square, and here it is minus 2x minus y, this minus 2x and this become minus y, and plus iota times x plus 2y is equal to 0. So if we compare it, now we have the real term and the imaginary term, and it is equal to 0. It means this is 0 plus iota 0, or we can say that we can make it as x square plus y square minus 2x minus y is equal to 0. And from here we got x plus 2y is equal to 0. So from here we can, now we can solve with the help of we solve in the simultaneous equation. X is equal to minus 2y, and we'll put it here. We'll get 4y square plus y square minus minus plus 4y minus y is equal to 0, or it is 5y square plus 3y is equal to 0. So from here we will get y is equal to 0 or minus 3 over 5. If we'll solve it, we'll take y common and we'll get 5y plus 3 is equal to 0. So y is equal to 0 or y is equal to minus 3 by 5. So according to this, now we will get x also. X will be 0 or x is equal to minus 2 times this, so 6 over 5. So two values are 0 0 and 6 over 5 comma minus 3 by 5. We have two complex number, so z is equal to 0 plus iota 0, we will not accept it. So the answer for that is z is equal to, the solution z is equal to 6 by 5 minus 3 by 5 iota, or this is equal to 1 upon 5 common and 6 minus 3 iota. We could have taken 3 also, so it is going to be 3 by 5 times 2 minus iota. Whatever form, they all are acceptable. accepted. So the solution for this equation is z is equal to this, not this one. So I hope it is clear. Let's do the next part of this question. This is the B first part. On a single Argand diagram, sketch the loci given by the equation modulus z minus 2 iota is equal to 2. That is modulus z minus 0 plus 2 iota is equal to 2. So it means the center of circle is 0 comma 2, that is on y axis, and imaginary of z radius of this circle is going to be 2, this one, and imaginary of z is equal to 3, means it is on the y axis, a line y is equal to 3 type. So let's draw it on the single Argand diagram. So this is a circle with center 0 comma 2, and the line y is equal to 3 would be, suppose this is point 3 on imaginary axis this is 3 and it is a real axis. So on imaginary axis this is 3, so the line would be parallel to x axis. So this is imaginary of z is equal to 3, so it is passing through 3 and this intersect the circle at 2 points, and this is the origin. Now this is the sketch. Now let's do the next part. In the first quadrant, the two loci intersect at the point P. Find the exact argument of the complex number represented by P. So let's get back to the diagram once more. So it means in the first quadrant it intersected at this point, so it is P, and y coordinates we know it is going to be 3 because it means we need to find this angle. And how can we find this angle? We need to find the coordinates of this point first of all. So if y coordinate is 3 and this is given as circle, equation of circle, we have z minus 2 iota is equal to 2, then what would be the value of x coordinates here? So we can write the equation in the other form, like we know, if we know the radius and center, then it is going to be x square, or we can write it as x minus 0 square plus y minus 2 whole square is equal to radius square, that is 4. And if we put y is equal to 3 here, we will get x square plus 3 minus 2 1, so 1 square is 1 is equal to 4, or we can say x is equal to plus minus root 3. So here would be minus root 3, here would be plus root 3. It means this point is root 3. So once we got root 3, it means this is root 3 and this is 3. In order to get this value, this is what we are going to find. So tan theta will use, tan theta is 3 by root 3, or we can get it as tan theta multiplying and dividing by 3. So it would root 3, sorry, it is going to be 3 root 3 upon 3. So these two got cancelled, and we know that in first quadrant this is true for 60 degree or pi by 3. So it means theta, the argument is pi by 3. We can write in both, but we'll write in the radian. So the argument of this argument is theta, that is pi by 3. So I hope it is clear. So that's it for this video. We'll discuss the last 3 questions in the next video. Thank you so much.